Hello everyone. In this deeper dive video for Module 4, I just want to look into a little bit on how to solve slightly more complicated algebraic equations. So in Module 4 we talked about solving algebraic equations where basically we had to do one operation to solve it. So now we want to look at slightly more complex equations. This will be very important if you plan on taking Algebra 1. You will have to know all these techniques. So this is sort of a preview of Algebra 1. So let me start just by reviewing what we learned in this class in Module 4. So let's say you were asked to solve x minus 4 is equal to 16. Right? You want to solve that for x. So if you remember, we want to isolate the variable, right? You want to isolate the x. So the way to do that, since 4 is subtracted from x, if we add 4 to both sides, right? If I add 4 to the left-hand side, negative 4 plus 4 is 0. So then I have x plus 0, which is x, so I've isolated the x. But whatever I do to one side, I have to do the other side. So I have to also add 4 to the right-hand side. So then this will be x is equal to 20. And that would be the solution. And remember, we can check it by plugging it back in, right? If I plug this back into the original equation, so where I have an x, I plug in a 20. And notice that 20 minus 4 is 16, that equals 16, so it checks. So we know that we have the correct solution. But it was just a single step, right, to get that answer. Let me give you one more example. Let's say we had 2/3 x is equal to 20. Right, I want to solve that for x. So now, right, remember, x is being multiplied by 2/3. I want to get a 1x, right? I want to isolate the x, which means I want 1x. So the way that you can do that is you can multiply both sides by the reciprocal of 2/3. So if I multiply by 3/2, right, the reciprocal, but whatever I do to one side, I have to do to the other side. Why does that work? Because if I multiply 3/2 times 2/3, that just gives me 1x, which is x. And then the right-hand side, if I work this out, I can simplify a little bit, right? 2 goes into 2 once, 2 goes into 20 10 times. So this is going to be 3 times 10, 30, over 1 times 1 is 1, so this is a 30. So it looks like x is equal to 30. And that would be the solution, right? So again, we only had to do a single step, right? I had to multiply both sides by 3/2. By the way, remember the other way we could have done this is we could have divided both sides by 2/3, right? And that also would have given us the answer x equals 30. Okay, so now going a little further, what if we have a slightly more complex equation? Well, basically what we're going to do is we're going to combine these two properties. You can think of this as sort of like the addition property, which sort of includes subtraction, addition, subtraction property. And this is really like the multiplication property, which really includes division as well. So let's combine those two properties. So combining the addition and multiplication properties. Okay, so for example, let's say I want to solve this equation now. So 4x plus 5 is equal to 21. Okay, so the ultimate goal is the same, right? We want to isolate the variable on one side of the equation. We want to isolate that x. And then once we have it isolated, we can read off the answer. But now I can't do this in one single step, right? I have to do multiple steps. So the first thing you would do is we would try, since we can't immediately get the x by itself, let's see if we can get the 4x by itself. Yeah, we can do that if we subtract 5, right? See how 5 is being added to 4x? Well, if I subtract 5, that'll give me a 0 there. But whatever I do to one side, I have to do to the other side. So this is going to be 4x is equal to, and then 21 minus 5 is 16. Okay, so I've reduced my equation. It's an equivalent equation now. 4x is equal to 16. And now to get x, or 1x by itself, what do? Well, I need to divide by 4. Right, so let me write it over here. So I have 4x is equal to 16. If I divide by 4, whatever I do to one side, I do the other side. These cancel, right? So that's 1x, which we can just write as x. And what's 16 divided by 4? That's 4. So the solution here would be x is equal to 4. So really all we're doing is we're doing multiple steps, right? Instead of solving the equation in a single step, we have to use several steps. Let's do a few more examples. Let's say we want to solve y over 3, which is the same as 1/3 y. Well, I'll write it as y over 3 plus 3 is equal to 42. I want to solve that for the variable y. Okay, so let's start. Well, we can't immediately just isolate the y, but we can isolate the y over 3, right? I could isolate that by subtracting 3. I get rid of this 3. I can subtract 3 from both sides. So that gives me y over 3 is equal to, and then 42 minus 3 is 39. So now how do I solve for y now? How do I get 1y? It's being divided by 3. Well, to undo that, we could multiply by 3, right? The other way to think about this is, really right now we could also write this as 1/3 y is equal to 39. And remember, to get a 1 in front of the y, I can always multiply by the reciprocal. Well, the reciprocal of 1/3 is 3 over 1, right? So really I'm multiplying both sides by 3. So these cancel, right? 1 over 1. I'm going to get 1y, which is y. And then 3 times 39 is 117. And that would be my answer. So y equals 117. But again, to solve that, we had to do 2 steps, right? I had to subtract 3 from both sides first. That gave me y over 3 is equal to 39. And then to isolate the y, to get 1y, I had to multiply both sides by 3 so that the 3's canceled, right? Or you can think of it as multiplying by 3 over 1. And then finally I got y is equal to 17. Okay, now sometimes you need to combine like terms first. Let me just do one more example here. So I'll say sometimes you need to combine like terms first. So let's say I want to solve this equation. So I want to solve 3x plus 5x plus 2 is equal to 7 plus 11. Okay, so first of all, what are like terms? Well, like terms are terms that have the same variable, right, to the same power. And also numbers, right, constants are also like terms. So in this case, see how I have 3x, right? This is like x to the 1 power, and then 5x to the 1 power. These are like terms. So these right here are like terms. And then on this side, on the right-hand side, I have 7 plus 11. They're just numbers. I can combine them. These are also like terms. So how do I combine like terms on the left-hand side? What is 3x plus 5x? Well, you might expect this to be 8x, and that's correct, right? Think of it, x is like apples, right? So this is like 3 apples plus 5 apples is 8 apples. So 3x plus 5x is 8x. When you study algebra in more detail, we'll talk more about what's called the distributive property, and this can be shown using the distributive property. But intuitively, right, it's 8x. So plus 2, and then the right-hand side, I can combine those constants. They're also like terms. What's 7 plus 11? That's 18. Okay, so I had to do that first. I had to combine like terms first. Now we can solve it using our techniques. Well, I want to isolate the 8x. So what do I need to do first? Well, I need to subtract 2 from both sides. Right? I need to get rid of that 2. Let me write this down again. So I will subtract 2 from the left-hand side. That gives me a 0 there, right? 2 minus 2 is 0. But whatever I do to one side, I also have to do to the other side. So now I have 8x is equal to 16. And then finally, to get x by itself, to get 1x, I can divide both sides by 8, right? Since it's being multiplied by 8, if I divide by 8, it sort of undoes that. It gives me a 1 there. But whatever I do to one side, I have to do the other side. So I'm going to get x equals, and then 16 over 8 simplifies to 2. So my solution here to the original equation is x equals 2. So if you were to plug 2 back in here and here, right, wherever you have an x, you're going to find that both sides are equal, right? So it is the actual solution. You can always check it, right? 3 times 2 is 6, plus 5 times 2 is 10. So 6 plus 10 is 16, plus 2 is 18, and that equals 18, which is the other side. So we know that that is the solution. Okay, so again, all I want to do was a couple of examples, kind of give you a little taste of what you'll see in Algebra 1 when you take Algebra 1. Great, thanks.